In this video, we'll talk about loops. Here's an example of code with a while loop. You see the while keyword, followed by a conditional expression and a colon. Below that, and indented one level, you see the loop body. Now let's execute this code. At the top left, you see our execution arrow, and we have a box for our output. We'll move the execution arrow until we reach a function, main. We will step into that function and begin executing statements there. To compute the value of x, we'll make a function call to g, passing the values 2 and 9 for a and b, and execute statements in g. Total is initialized with a value of 0, and then we get to our loop. We evaluate the conditional expression after the while keyword. In this case, a less than b takes the values 2 less than 9, which is true. When the loop guard evaluates to true, we move the execution arrow into the while loop and execute statements there. We will change total to be the value total plus a, and then print the current values of a and b to our output. Increment a by 1, decrement b by 1, and then we reach the word pass. This is optional, as it just means don't do anything. Python interprets statements by their level of indentation, but including the word pass at the end of a loop tells our editor that on the next line we don't want to indent to that level, and it helps us keep from making mistakes. Once we reach the end of the loop body, we will return execution to the top of the while loop and evaluate the loop guard again. This time, a less than b means 3 less than 8, which evaluates to true, so we enter the loop body, add a to total, print the current values of a and b, increment a, decrement b, and we've reached the end of the loop body. So we'll return execution to the beginning and evaluate the loop guard again. A less than b is 4 less than 7, which is true, so we enter the loop again, add a to our total, print the current values of a and b, increment a, decrement b, and we've reached the end. So we'll go back to the top and evaluate the loop guard. 5 less than 6 is true. We enter the loop and evaluate the statements inside. We've reached the end. Go back to the beginning and evaluate the loop guard. This time, 6 less than 5 evaluates to false. When the conditional statement evaluates to false, we move execution arrow just past the end of the loop and execute statements again as normal. The first statement we encounter after the while loop is return total. So we will return the current value of total, 14, to call site location 1, assign that value to x, and continue executing statements in main. Print the value of x, and we've reached the end of main and the end of our program. Now we're going to talk about a feature of Python called the range function, which generates a range object. This function takes an optional first argument start, a required argument stop, and an optional argument step. Here's an example where we only supply the value of stop. By default, we start counting at 0, step by 1, and continue counting as long as the value we count is less than stop. So in this case, we count 0, 1, 2, and 3 is not less than 3, so we stop counting. Here's a call to range where we supply the optional first argument, which means we want to start counting at 1. We'll count 1, 2, and stop at 3. So our range object contains the values 1 and 2. Here's an example where we supply a value for step. So we start counting at 1, stop counting at 5, and step by 2 each time. So we start at 1, step by 2, count 3, and the next thing we would step is 5, but that isn't less than 5, so we stop. And our range object contains the values 1 and 3. You may wonder why we're talking about the range function in a video about loops, and the answer is that ranges can be used in for loops, which are syntactic sugar for while loops to make code easier to write. Here's an example of a for loop. You see the for keyword, and then an expression that means I will take the values that are in the range object, in this case 1 and 2, and the loop body will execute for each value that I takes. We could write code that functions in the exact same way with a while loop. This is what we mean by syntactic sugar. We did not provide additional functionality by the for loop, but it does make our code a little bit simpler. So the equivalent while loop has I initialized before the loop begins, a conditional statement that we count as long as I is less than n, and we increment I, the last thing we do in the body of the while loop before we go through it again.